Dear students, today we see about multi-degree of freedom suspension system. Aim of the experiment to determine the natural frequency of multi-degree of spring mass system and damping coefficient. This is the experimental setup for the multi-degree of freedom spring mass system. So this is the helical spring, spring 1 and spring 2. This spring 1, spring 2 is connected at the series connection. Now we are going to see about the pictorial representation of the experiment. This is the pictorial representation of the spring mass system. So here we connect the spring 1 in the fixed end. At the another end of the spring we have to connect the or add the mass and then the timer and also the base fixed beam setup we going to attached to the base. Formula used, stiffness of the spring K is equal to GD power 4 divided by 8D cube. Here D, capital D is outer diameter of the coil and small d is inner diameter of the coil, and G modulus of rigidity. Natural frequency omega n is equal to root of K by M. K is equal to stiffness of the spring and M is equal to mass added to the system. Damping frequency, omega d is equal to root of 2 pi divided by Td. So Td means time taken for one oscillation, and damping coefficient C is equal to 2 into epsilon into M into omega n. So this formula we are going to calculate the damping coefficient. So this is the tabulation for model calculation. So for this first column weight added and then time taken for one oscillation, we are going to measure with the timer or stopwatch, and damping frequency omega d we are going to calculate by using the formula, and then damping factor and also we calculate by using the formula, and finally damping coefficient we have the formula 2 into epsilon into M into omega n. So this formula we are going to calculate the damping coefficient. Now we are going to do the experiment. So now we are going to take the reading without masses, so that is 0 mass. Now we are going to oscillate the spring setup. So first we are going to pull and release the some distance. Now we take the one oscillation from the timer. So for this oscillation we got the 1.75 seconds, and then we are going to reset the timer and we are going to add the 100 grams mass, and then we are going to oscillate again. So 15.31 seconds we are going to got the per 100 grams mass, and now we are going to add another 100 grams. Now next we added the 200 grams. We got the timing one oscillation time taken, and then we go for the model calculation, and then we take the three readings for 0 mass and 100 gram and 200 gram. So time taken will be noted, and then damping frequency, damping factor and damping coefficient we are going to calculate. So result, thus the natural frequency of the various spring and damping coefficients are found out. Thank you.